The phenomenon of human aging is inextricably linked to a profound and progressive decline in neuromuscular function, a condition clinically defined as sarcopenia, which represents one of the most debilitating physiological transformations experienced by the elderly population. This insidious process is not merely a cosmetic loss of muscle mass, but a catastrophic degradation of metabolic vitality, functional independence, and structural integrity that drastically elevates the risk of falls, fractures, and all-cause mortality. At the microscopic core of sarcopenia lies a highly specific and destructive pattern: the preferential atrophy and apoptosis of type 2 fast-twitch muscle fibers. These large, powerful, and metabolically demanding fibers are responsible for explosive movements, rapid reflex corrections to prevent falls, and the generation of maximal force. However, as the human body advances in age, the motor neurons innervating these type 2 fibers undergo gradual degeneration. When a motor neuron dies, the corresponding muscle fibers it controls are left orphaned. While some of these orphaned fibers may be reinnervated by nearby slow-twitch type 1 motor neurons, thereby converting their characteristics to slow-twitch, millions of others simply wither away in a process of irreversible apoptosis. Consequently, the aging muscle not only shrinks in cross-sectional area but undergoes a fundamental shift in its architectural composition, becoming slower, weaker, and highly infiltrated by adipose tissue and fibrotic collagen, a state known as myosteatosis. For decades, the universally prescribed antidote to this muscular decay has been conventional resistance training, which typically involves lifting progressively heavier weights through a full range of motion. While the hypertrophic benefits of traditional weightlifting are scientifically indisputable, this approach presents a formidable and often insurmountable barrier for the aging demographic. The dynamic nature of concentric and eccentric muscle contractions, particularly under heavy loads, subjects the articular cartilage, ligaments, and tendons to immense shearing forces and mechanical stress. In older adults, whose joints are frequently compromised by osteoarthritis, degraded synovial fluid production, and diminished collagen elasticity, traditional dynamic weightlifting frequently exacerbates joint pain, triggers acute inflammatory cascades within the joint capsule, and leads to severe microtrauma in the connective tissues. This biomechanical reality creates a cruel paradox. The very exercise required to save the aging muscle threatens to destroy the aging joint. It is within this complex physiological conundrum that a revolutionary paradigm of muscular rehabilitation emerges, focusing on a 10-minute protocol of highly precise, sustained static muscle contractions to rapidly regenerate senescent muscle fibers without inflicting any mechanical stress upon the vulnerable joints. This innovative methodology bypasses the deleterious joint shearing forces of dynamic movement by relying entirely on the principle of sustained, immovable tension, effectively forcing the cellular machinery of the aging tissue to adapt and synthesize new myofibrillar proteins through pure mechanical and metabolic stress. To comprehend the profound efficacy of this 10-minute static contraction protocol, one must delve deeply into the neurophysiology of motor unit recruitment, specifically the Henneman Size Principle. Under normal physiological conditions, the central nervous system recruits motor units in a strict, sequential order based on their size and activation thresholds. For low-intensity tasks, such as walking or holding a light object, the brain recruits only the small, fatigue-resistant type 1 slow-twitch fibers. The large, powerful type 2 fast-twitch fibers remain dormant, conserved strictly for emergencies or maximal effort tasks, which older adults rarely, if ever, perform in their daily lives. Because they are never activated, these type 2 fibers atrophy from disuse long before neurological degradation takes its toll. The genius of the sustained static contraction protocol lies in its ability to therapeutically hack the Henneman Size Principle. When an older adult engages in a continuous, unyielding static hold, creating intense tension within the muscle belly without changing its length or moving the adjacent joints, they initiate a rapid cascade of cellular fatigue. Within the first minute or two of the sustained contraction, the type 1 slow-twitch fibers begin to exhaust their localized ATP reserves. As these primary fibers fail, the brain recognizes that the required tension is not being met. To maintain the static hold, the central nervous system is forced, out of sheer necessity, to recruit progressively larger motor units. by the third or fourth minute of an appropriately intense static contraction. The once dormant type 2 fast twitch fibers are inevitably summoned into the contraction to share the load. This phenomenon effectively resurrects the most neglected and vulnerable muscle fibers in the elderly body. Through a continuous 10-minute protocol involving multiple targeted static holds, these fast twitch fibers are subjected to profound stimulation, reversing the use it or lose it paradigm without the need to lift a heavily weighted barbell or strain a fragile knee or shoulder joint. Simultaneously, this method of sustained static tension initiates a highly potent biological signaling cascade known as mechanotransduction, the fundamental process by which cells convert mechanical forces into biochemical signals. In the context of skeletal muscle, the sarcolemma or muscle cell membrane is embedded with specialized transmembrane receptors known as integrins. These integrins act as mechanical sensors, physically connecting the extracellular matrix to the internal cytoskeleton of the muscle fiber. When a muscle is subjected to intense, prolonged static tension, the sheer physical pull across the membrane violently distorts the shape of these integrins. This mechanical distortion triggers the activation of focal adhesion kinase, FAK, an enzyme located precisely at the point where the integrin meets the internal cell structure. The activation of FAK is the first domino in a breathtakingly complex intracellular signaling pathway that ultimately commands the cell to grow. FAK stimulates the phosphoinositide 3 kinase, PI3K, and protein kinase B, ACT, pathway, which subsequently converges on the master regulator of cellular anabolism, the mammalian target of rapamycin complex 1, mTORC1. mTORC1 serves as the crucial command center for muscle growth. When it is activated, it orchestrates the intricate machinery of the cell to begin manufacturing new proteins. Specifically, mTORC1 phosphorylates 2 key downstream targets, P70S6K and 4EBP1, which drastically upregulate ribosomal biogenesis and the translation of messenger RNA, mRNA, into new actin and myosin filaments. In younger individuals, traditional weightlifting triggers this pathway through microscopic muscle damage, relying on the inflammatory repair process to build the muscle back larger and stronger. However, in older adults, systemic inflammation is often already chronically elevated, a condition termed inflammaging, and introducing severe muscle damage through eccentric exercise can overwhelm their weakened recovery capacities, leading to delayed onset muscle soreness, DOMS, that lasts for weeks and discourages further exercise. The beauty of static contraction training is that it achieves monumental activation of the mTORC1 pathway almost entirely through mechanical tension and metabolic stress, bypassing the need for severe muscular microtears. By removing the damaging eccentric or lengthening phase of muscle contraction, the 10-minute protocol stimulates massive protein synthesis and structural regeneration while leaving the muscle tissue largely intact and free from debilitating pain, allowing the elderly individual to train consistently without requiring extensive recovery periods. Equally critical to the success of this static contraction protocol is the profound metabolic stress it induces within the local muscle environment, a factor that is exceptionally catalytic for anti-aging physiological responses. When a muscle is contracted statically and held at an intense level of tension, the internal pressure generated by the bulging muscle fibers physically compresses and occludes the local capillary beds. This capillary occlusion drastically restricts both the inflow of oxygenated arterial blood and the outflow of venous blood containing metabolic waste products. This temporary, localized ischemic environment forces the active muscle fibers to abandon oxygen-dependent aerobic respiration and rely almost exclusively on anaerobic glycolysis to generate the adenosine triphosphate, ATP, necessary to sustain the contraction. As glycolysis rapidly accelerates, the muscle cells produce copious amounts of lactic acid, which dissociates into lactate and hydrogen ions. The accumulation of hydrogen ions causes a sharp, localized drop in the intracellular pH, creating an incredibly acidic environment within the muscle belly. While this acidosis produces the characteristic burning sensation of intense exercise, it is also one of the most powerful anabolic triggers known to mammalian physiology. The acute localized hypoxia and plummeting pH are detected by the central nervous system through group 3 and 4 afferent nerve fibers. In response to this severe metabolic distress signal, the anterior pituitary gland orchestrates a massive systemic release of human growth hormone, HGH. Concurrently, the metabolic stress stimulates the local production of insulin-like growth factor 1, IGF-1. Specifically the mechanogrowth factor, MGF, splice variant, directly within the active muscle tissue. The synergistic interplay between circulating growth hormone, localized IGF-1, and mechanical tension creates an overwhelmingly anabolic environment that commands the senescent muscle cells to reverse their catabolic trajectory and begin synthesizing new tissue. Furthermore, this intense metabolic accumulation acts as a potent stimulus for satellite cell activation. Satellite cells are the resident stem cells of skeletal muscle, located quietly between the basal lamina and the sarcolemma of the muscle fiber. In aging populations, the pool of satellite cells naturally diminishes, and the remaining cells become sluggish and unresponsive, severely limiting the muscle's ability to repair and grow. The combination of sustained static tension, localized hypoxia, and elevated growth factors chemically wakes up these dormant satellite cells. They rapidly begin to proliferate and migrate toward the stressed muscle fibers, eventually fusing with the existing damaged or atrophied cells. Upon fusion, these satellite cells donate their nuclei to the host muscle fiber, effectively expanding the myonuclear domain. Because a single nucleus can only manage a specific volume of cellular fluid and protein, the addition of new nuclei provided by satellite cell fusion permanently increases the genetic capacity of the aging muscle fiber to manufacture protein, resulting in profound and long-lasting muscular hypertrophy that turns back the biological clock on sarcopenia. Beyond the localized cellular and structural adaptations, the 10-minute static contraction protocol exerts a remarkable regenerative influence on the aging nervous system, explicitly targeting the delicate interface where mind and muscle meet, the neuromuscular junction, NMJ. The aging process often inflicts severe structural degradation upon the NMJ. The nerve terminals begin to fragment, and the tightly clustered acetylcholine receptors on the muscle membrane disperse, leading to inefficient signal transmission, muscle weakness, and a loss of fine motor control. When older adults engage in sustained static tension, the uninterrupted flow of action potentials descending from the motor cortex to the muscle forces a biological stabilization of the NMJ. The high-frequency, sustained firing rates required to maintain a prolonged static hold stimulate the expression of agrin, a critical nerve-derived protein that binds to receptors on the muscle fiber and actively herds acetylcholine receptors back into dense, efficient clusters. This synaptic remodeling ensures that every neurological command sent from the brain is translated into a forceful muscular contraction with minimal signal loss. Moreover, the act of maintaining a difficult static hold requires intense neurological focus and concentration, fostering robust neuroplasticity within the primary motor cortex and the supplementary motor areas of the brain. Older adults frequently suffer from a degradation of the corticospinal tract, which contributes to the slowing of reaction times and the loss of balance. By engaging in high-intensity isometric holds, they are functionally laying down new neural pathways, increasing corticospinal excitability, and enhancing the synchronization of motor unit firing patterns. This neurological revitalization translates directly into improved functional strength. Even if the physical size of the muscle were to remain unchanged, the elderly individual would experience a dramatic increase in strength simply because their brain has become vastly more efficient at communicating with the muscle tissue. The lack of complex, multi-joint movement in static training also removes the need for immense proprioceptive processing, allowing the central nervous system to direct all of its resources purely toward maximizing force production and motor unit recruitment, making it an incredibly potent neurological training tool. However, the miraculous biological processes initiated by mechanical tension and metabolic stress cannot manifest in a vacuum. They are entirely dependent upon the presence of specific nutritional building blocks to complete the architectural reconstruction of the aging muscle. To reverse sarcopenia and capitalize on the signals generated by the 10-minute static workout, the elderly individual must overcome a physiological hurdle known as anabolic resistance. In youth, the ingestion of a relatively small amount of dietary protein is sufficient to profoundly elevate muscle protein synthesis. As the body ages, the gastrointestinal tract becomes less efficient at digesting and absorbing amino acids, and the muscle tissue itself becomes blunted or resistant to the anabolic signals of these nutrients. To break through this wall of anabolic resistance, the dietary strategy must be aggressive and highly specific, focusing intensely on the essential amino acid leucine. Leucine is not merely a structural component of muscle. It is a powerful signaling molecule that acts as the key to unlock the mTORC1 pathway. Following the static contraction protocol, when the muscle cells are primed and screaming for nutrients, the introduction of a high leucine protein source, such as whey protein isolate, lean meats, or specialized amino acid supplements, triggers a massive spike in intracellular leucine concentrations. This spike binds to a protein complex called cestrin-2, pulling it away from a secondary complex called gator-2, which is then free to fully and powerfully activate mTORC1. For an older adult, the threshold of leucine required to trigger this cascade is significantly higher than that of a younger person, often necessitating doses of 3 to 4 grams of leucine per meal. The precise timing of this nutritional intervention, often referred to as protein pacing, involves distributing these high leucine, high-quality protein feedings evenly across the day to create multiple, distinct spikes in muscle protein synthesis, effectively keeping the body in a constant state of repair and regeneration. This protein intake must be complemented by adequate hydration, as cellular swelling itself is an anabolic signal, and sufficient carbohydrate intake to replenish the glycogen stores rapidly depleted during the intense anaerobic glycolysis of the static holds. The metabolic stress of the workout dramatically increases the sensitivity of the muscle cells to insulin, prompting the translocation of GLUT4 transport proteins to the cell membrane. These transporters act like vacuum cleaners, pulling glucose out of the bloodstream and into the muscle to be stored as glycogen. This localized improvement in insulin sensitivity is a profound systemic benefit, actively combating the insulin resistance and type 2 diabetes that plague the aging population, and transforming the rehabilitated muscle tissue into a massive metabolic sink for circulating blood glucose. Furthermore, the nutritional synergy required to support this rapid muscular regeneration extends deep into the realm of micronutrients and essential fats, particularly focusing on the modulation of systemic inflammation and the preservation of cellular membrane fluidity. As previously noted, the elderly often suffer from chronic low-grade inflammation, a biological state driven by elevated levels of circulating cytokines such as interleukin-6, IL-6, tumor necrosis factor alpha, TNF-alpha, and C-reactive protein, CRP. This systemic inflammation creates a highly catabolic environment that directly interferes with the mTORC1 pathway and actively promotes muscle protein breakdown. To counteract this, the integration of high-dose omega-3 polyunsaturated fatty acids, specifically eicosapentaenoic acid, EPA, and docosahexaenoic acid, DHA, becomes an indispensable component of the rehabilitative protocol. Omega-3 fatty acids incorporate themselves into the phospholipid bilayer of the muscle cell membrane, enhancing its fluidity and profoundly improving the cell's sensitivity to both mechanical tension and anabolic hormones like insulin and IGF-1. More importantly, EPA and DHA serve as precursors to specialized pro-resolving mediators, SPMs, such as resolvins and protectins, which actively extinguish systemic inflammation, thereby shielding the newly forming muscle proteins from catabolic degradation. Concurrent with omega-3 supplementation, the optimization of vitamin D levels is of paramount importance. Vitamin D is not merely a vitamin but a potent secosteroid hormone that binds to the vitamin D receptor, VDR, located directly on the muscle tissue, particularly on the vulnerable type 2 fast twitch fibers. Adequate levels of vitamin D are essential for calcium homeostasis within the sarcoplasmic reticulum, the organelle responsible for releasing the calcium ions necessary to initiate a muscle contraction. A deficiency in vitamin D leads to profound muscle weakness, delayed relaxation times, and a severely blunted hypertrophic response to exercise. When vitamin D stores are optimized, the efficiency of calcium handling within the muscle improves dramatically, allowing for the generation of much higher levels of tension during the static holds, thereby maximizing the mechanical stimulus sent to the mTORC1 pathway. Additionally, intracellular minerals such as magnesium and zinc must be maintained at optimal levels, as magnesium is a required cofactor for the stabilization of ATP molecules, and zinc plays a critical role in the structural integrity of the ribosomes that are actively manufacturing the new myofibrillar proteins. Transitioning from the intricate world of cellular biology and nutrition, one must address the profound psychological and emotional barriers that often prevent the elderly from engaging in physical rehabilitation, a domain where the 10-minute static contraction protocol proves to be singularly transformative. Among the aging population, the prevalence of kinesiophobia, the intense, irrational fear of movement and physical activity resulting from a feeling of vulnerability to painful injury or injury, is staggering. When an older adult is presented with the prospect of lifting weights, the brain perceives the dynamic exercise as a severe existential threat, triggering the amygdala and initiating a massive fight-or-flight response. This sympathetic nervous system overload floods the body with cortisol, a highly catabolic stress hormone that actively breaks down muscle tissue, suppresses the immune system, and directly inhibits the anabolic pathways required for recovery. Furthermore, the anxiety associated with balancing a heavy load often results in erratic, unsafe biomechanics, increasing the actual risk of the very injury the individual fears. The implementation of sustained static contractions dismantles this psychological barrier entirely. Because the protocol involves no movement of the joints, no balancing of external loads, and no complex choreography, the perception of threat is drastically reduced. The individual is in complete, absolute control of the intensity. If a sensation of pain or discomfort arises, they can instantly cease the contraction without the danger of a heavy weight crashing down upon them. This profound sense of autonomy and safety calms the central nervous system, down-regulating the sympathetic fight-or-flight response, and allowing the parasympathetic rest and digest nervous system to govern the physiological environment. In this relaxed neurological state, cortisol levels plummet, and the body becomes incredibly receptive to the anabolic signals generated by the static tension. As the elderly individual safely completes the 10-minute protocol day after day, experiencing the deep muscular fatigue without the accompanying joint pain, a powerful psychological phenomenon known as self-efficacy begins to take root. They realize that their bodies are not fragile, broken vessels, but rather resilient, adaptable organisms capable of generating immense internal force. This restoration of physical confidence ripples outward, dramatically altering their daily behavior. They become more willing to engage in daily activities, walk further distances, and participate in social events. This psychological empowerment is deeply intertwined with the systemic endocrine shifts induced by the active muscle tissue itself, elevating the status of the skeletal muscle from a simple mechanical apparatus to a vital, life-sustaining endocrine organ. Historically, skeletal muscle was viewed purely as a motor designed to move the skeleton. However, contemporary molecular biology has revealed that actively contracting muscle fibers operate as an immense glandular system, producing and releasing hundreds of powerful signaling peptides known as myokines. When the aging muscle is subjected to the intense metabolic stress and sustained tension of the 10-minute static protocol, it releases a flood of these highly beneficial myokines, most notably interleukin-6, IL-6, produced locally within the muscle, and irisin. While chronically elevated IL-6 from the immune system is a marker of inflammation, the acute, transient burst of IL-6 produced by contracting muscle fibers acts in a completely contrary manner. It operates as a potent anti-inflammatory agent, actively suppressing systemic inflammation. Even more remarkable is the release of irisin, a myokine cleaved from the FNDC5 membrane protein during intense muscular exertion. Irisin travels through the bloodstream and acts directly upon white adipose tissue, the dangerous, metabolically inactive visceral fat that accumulates around the organs of aging individuals. Irisin triggers a profound genetic reprogramming within these white fat cells, upregulating the expression of uncoupling protein 1, UCP1, and effectively converting the white fat into metabolically active beige fat. This beige fat acts like a cellular furnace, burning stored calories simply to generate body heat, thereby radically increasing the individual's basal metabolic rate and combating the creeping obesity that so often accompanies sarcopenia. Furthermore, these muscle-derived myokines cross the blood-brain barrier, exerting direct neuroprotective effects on the brain. They stimulate the production of brain-derived neurotrophic factor, BDNF, in the hippocampus, a protein critical for the survival of existing neurons and the growth of new synapses. Thus, the intense, highly focused effort required to maintain a static muscle contraction for 10 minutes not only rebuilds the architecture of the body but actively defends against cognitive decline, dementia, and neurodegenerative diseases, linking the vitality of the physical muscle directly to the longevity and clarity of the human mind. The practical application of this paradigm-shifting protocol is remarkably elegant in its simplicity, requiring no specialized gym equipment, no expensive memberships, and no excessive time commitments. The entire methodology is predicated on the individual creating maximum internal tension against an immovable object, which could be a sturdy door frame, a heavy piece of furniture, a specialized static strap, or even the opposing limbs of their own body. The fundamental goal is to place the target muscle into a mechanically advantageous mid-range position, where the actin and myosin cross-bridges overlap optimally to produce the greatest amount of force, and then deliberately and consciously contract the muscle as intensely as safely possible for a sustained duration. For example, to target the rapidly atrophying type 2 fibers of the quadriceps, which are critical for standing up from a chair and preventing falls, an older adult might press their back against a wall, lower themselves into a partial squat position that does not cause pain in the osteoarthritic knee joint, and simply hold that position. Within seconds, the localized hypoxia and accumulation of lactic acid will begin to burn. Within a minute, the slow-twitch fibers will fail, and the powerful, dormant fast-twitch fibers will be violently recruited. It is during these agonizing but safe final seconds of the hold that the biological magic occurs, maximizing mechanotransduction, mTORC1 activation, and myokine release. The individual then rests, allowing blood to rush back into the tissue, clearing out the metabolic waste and delivering oxygen and nutrients, before moving on to the next muscle group. A full-body routine can be meticulously completed in exactly 10 minutes of total time under tension. A crucial caveat during this intense physiological exertion is the meticulous management of respiration. Inexperienced individuals instinctively hold their breath when generating immense force, a dangerous reflex known as the Valsalva maneuver, which causes a rapid, massive spike in intrathoracic pressure and a dangerous elevation in blood pressure, potentially triggering a cardiovascular event in compromised individuals. Therefore, the protocol strictly mandates continuous, rhythmic diaphragmatic breathing throughout the duration of the static hold. The individual must forcefully exhale through pursed lips, almost as if blowing out a candle, during the most intense phases of the contraction, ensuring a steady flow of oxygen, stabilizing blood pressure, and maintaining a strong engagement of the deep transverse abdominis muscles to protect the lumbar spine. Ultimately, the utilization of a 10-minute static, isometric contraction protocol represents a monumental leap forward in the science of geriatric rehabilitation and longevity medicine. For decades, the medical community has passively accepted the slow, painful decay of sarcopenia as an inevitable consequence of the aging process, offering little more than palliative care and advice to stay active, a vague prescription that fails to address the specific, microscopic destruction of the type 2 fast-twitch muscle fibers. Conventional dynamic exercise, while effective for the young and robust, has proven to be a double-edged sword for the elderly, often accelerating joint destruction and promoting debilitating inflammation in a futile attempt to save the muscular system. By stripping away the hazardous variable of mechanical joint movement and distilling the stimulus down to pure, unadulterated, sustained tension, we bypass the biomechanical frailties of the aging body and communicate directly with the cellular machinery. We exploit the foundational laws of human neurophysiology, manipulating motor unit recruitment patterns to awaken dying muscle fibers. We weaponize metabolic stress, turning localized hypoxia and lactic acid into powerful triggers for systemic growth hormone release and stem cell activation. We provide a safe, profoundly effective psychological environment that eradicates the fear of injury and restores physical autonomy to individuals who have felt betrayed by their declining bodies. This is not merely an exercise routine. It is a highly calibrated biological intervention, an intense, 10-minute cellular dialogue that commands the senescent tissues to rewrite their genetic destiny, reverse the catabolic tide of aging, and rapidly rebuild the structural and metabolic foundation necessary for a vibrant, independent, and fiercely capable life. The aging muscle is not a lost cause. It is simply waiting for the right signal, and sustained static tension is the ultimate, undeniable command to grow.